using the technology of today, what we see when we look at the picture is microbes that are very specific to each person. And so in that respect, we could say that the gut microbiota can be considered as at least giving the same information as a fingerprint could give. But it's a simplistic way to put things, because there are also conserved components within the microbiota. So one illustration is that if we use our technology to take the picture of the microbiota of one person over time, then we see very stable elements, and so we see the fingerprint stable over time. And then if we look at one person and another, then we have major differences that are their own fingerprint separation. We started with 17 Dutch and French individuals in the year 2009, and from that study we were able to identify 60 species that are conserved among at least 50% of the population, the small group we studied. And since we have studied many more, we have data for hundreds, and we do identify what we call a core microbiota, which is conserved among the human population. In terms of gene description, the genes of the genome, we have characterized 10 millions of genes of gut microbiota, and we know exactly those that are conserved. And those might be the most relevant actually for the clinician or for the nutritionist. We looked for the similarity between individuals. We looked for the specificity between individuals, and the next question for us was, is there an average gut microbiota? The average person, the one in the middle of the distribution, and in fact we did not find that. We find a distribution in groups of individuals that have different arrangements of microbes. We find that these probably correspond to different ecological arrangements, so it's groups of species that have things to exchange together, and if they arrange like that during the first years of life, then you stabilize that and you will carry that for most of your life. But it can be 3 different settings as we see it today.